In this video, we are going to be looking at rational functions and finding horizontal asymptotes. So we're not going to really take into account the range all that much in this video, so I'm just going to cross that out. Now, a horizontal asymptote it occurs when a function approaches a specific value but does not reach that value. So we have some rules over here on the right. So we have our rational function f of x. Okay, and we have our polynomial in the numerator and a polynomial in the denominator. And our highest degree in the numerator is a degree of m, and our highest degree in the denominator is a degree of n. So if m equals n, if the degrees are a tie, okay, if they're both equal to each other, then we have a horizontal asymptote at the ratio of those coefficients a and b. If the degree of the numerator is greater than the denominator, then there is no horizontal asymptote. And if the degree of the denominator is greater than the numerator, and is greater than m, then we have a horizontal asymptote at 0. So let's look at some examples. We have 2x squared plus 1 over x plus 1 in example A. We're looking at the term with the highest degree in both the numerator and the denominator. So our numerator has a greater degree than our denominator. Okay, I'm writing this statement. I'm not saying the numerator is greater than the denominator, but that the degree of the numerator is greater than the denominator. So when that occurs, there is going to be no horizontal asymptote. Okay, that is our second example here. Okay, off to the right in our notes. So there's no horizontal asymptote. Why is that? Well, if you just think about it, if you plugged in some values in for x into this function, the numerator gets bigger a lot faster than the denominator. And when the numerator gets bigger, faster, the value of this fraction just goes up and up and up and up and up. And f of x just gets greater and greater, so it approaches infinity. So we could even write that as x gets bigger and bigger and bigger, the value of the whole function gets bigger and bigger and bigger. Okay, but we're asked to find the horizontal asymptotes, and in part A there was not one. Part B, let's look at part B. So we have x squared minus x minus 2 over x squared minus x, taking the term with the greatest degree in both the numerator and the denominator. Notice here, the degree of the numerator is equal to the degree of the denominator. And if we look over on our notes to the right, we're looking at bullet 1. When this occurs, we have a horizontal asymptote at y equals the coefficient of both of those terms. So the coefficient in the numerator of x squared is 1, and the coefficient of x squared in the denominator is 1. So our horizontal asymptote is at y equals 1. So if we were to graph this, we would get a horizontal asymptote at 1. And the graph is going to do, what the graph is going to do, but it's going to eventually ride along that horizontal asymptote. Let's take a look at that, okay? I have that function graphed here. Okay, now you could see if I graph the line y equals 1, okay, that the horizontal asymptote is in green. Okay, so green is not part of the function, okay, but you could see that the graph way to the left rides along that horizontal asymptote. So it gets closer and closer to 1 but never reaches it. And on the right, it gets closer and closer to 1 but never reaches it. In our final example, we have 2x over 3x squared plus 1, so we're going to look at our two terms with the highest degree. So now the degree of our numerator is less than our degree of the denominator. And you could look at our notes here. Where is that gonna happen? So that happens in our third bullet. And when that occurs, we get a horizontal asymptote at y equals 0. And you could reason that out a little bit. As x gets larger, so x gets larger and larger and larger, our denominator gets bigger and bigger and bigger. It gets bigger faster than the numerator. And if the denominator of a fraction gets bigger, then the whole value of the fraction itself gets smaller. So as x gets bigger, I'm going to write this down. As x gets bigger, the denominator gets bigger. And when the denominator gets bigger, the fraction gets smaller. And it gets smaller and smaller and smaller the bigger x gets. So small that we say that the value of the function approaches 0. So our horizontal asymptote is at y equals 0. And we could see this in Desmos. Okay, so here we have this purple function. And notice if we look way to the left, the graph gets closer and closer to the x-axis, which is where y equals 0. And if we go to the right, the graph gets closer and closer to the x-axis. So that is our horizontal asymptote. So if you want to watch more of how to graph rational functions, you can check out the next video in this series.